right, so in this first reaction, our instructions say to place a test tube in the test tube rack, and I've done so here, and then fill the test tube with about an inch of HCl solution. So you can see that right in here, and obtain a piece of magnesium, which is what we have right down here. Try and get you a better look at that. Try and see if it'll focus. I think I'm gonna have to bring you guys to that container so you can see these little itty bitty pieces of magnesium ribbon. And then it says to record your observations of the reactants before mixing. So I know these before observations are probably going to be the most boring out of all of them, because I don't expect anything to have happened. All I want is to set the stage, the foundation for what this stuff looks like now, so that then when we mix them and combine them and a chemical reaction happens, then we have the opportunity to observe what it looks like later, and we can get that whole change in there. It does no good to say it turned pink if we don't know what color it started at. If it was like red, then turning pink just means maybe it got diluted or something. That's kind of boring. So we have to tell the whole story, which is why you have that before, during, and after space on your observation sheet. And you need to make sure to get 3 to 5 good descriptive words in each one of those spaces. So think about the color, size, shape, state of matter, those types of things for what you're going to include in your description. You can pause the video wherever you'd like if you need a better description. And then all it asks us to do is drop the magnesium ribbon into our HCl. This is your during observations. And then it says to record observations again once the reaction is complete, and that will go in your after observations. Right now it says you might want to feel the test tube, and if you did do that, you would feel a little bit of heat there. It's a little bit warm. I expect it's getting hotter the more this reaction progresses. And I'll let this just kind of go and finish up, and then, like the directions say, I'm just going to go and dump this, whatever is left over, in the colander in the back sink. Pull this out, show you test tube. Okay, now it's time for reaction number 2. All right, so here in reaction number 2, it starts off by asking me to put 2 test tubes in our test tube rack, which I have done. And then we have each of these 2 chemicals here, and we're going to add a pipette full of each of them into both of these test tubes so we can observe it better. We needed to use these amber bottles to help protect it while we store it, so we can't really observe it very well in those bottles. So I'm just adding a little bit of each so that you can see it, observe it. I know these aren't the most interesting things to observe, but I will get you a close-up look at it in just a moment. Okay. And I have put each of those on the side where they're gonna kind of match your bottles. So you can kind of see what we've got on either side. Now I'll bring it in closer, get a close look at them. Remember, 3 to 5 descriptive words. And then it says to pour either of the test tubes into the other one and record our observations, both during the beginning of this reaction, and it's going to be a pretty quick one. So this is your during. Pull this out, let you see. And then I'm going to let this sit for a couple of minutes. We'll see if we can get an after observation after a little while. So I'm actually going to cut this together with a video. Probably going to wait about 10 minutes to come back and look at this one so you can really make sure that you see it after it's fully complete. So right now, getting you the best look at this as I can. Kind of focus up here. This edge. So you can kind of see it better. There's kind of less of it. But like I said, we will come back and look at this a little bit later. Coming back over here after probably more like 7 minutes, you can see our same test tube that we saw before has changed slightly, which is why I wanted to make sure to make some observations after some time had passed. Down, kind of, there we go. So, yeah. If I kind of sort of shake it up, it goes back to looking a lot like what it did before, although you can definitely tell, if I can get this to focus right, yeah, we got a little bit more movement visible in there now after everything's reacted. It's not quite as solid white, at least in my opinion, but make your own after observations. That should be it. Okay, so here we have what we need for reaction number 3. And the directions just tell us to pour some of this copper to chloride, about 1 inch of it, into this little beaker. Not really measuring it, just approximating. And then it wants us to attach a cap to this 9-volt battery. And I'm going to do that. And what this cap is attached to are 2 long wires that are actually connected to these weird stick things. These are actually pencil lead or graphite. It's pure carbon in there, and I'm telling you that not because carbon is going to be part of the reaction, but because graphite specifically is non-reactive. So it's not going to be participating in this reaction. So the only stuff we've got here is the CuCl2. Now it mentions not to touch the little sticky things, the electrodes to each other. We are just going to carefully place these into that beaker. All they're doing, I know it's a little tough to record. So let's get the first one in there. And then the second one. Once they're both in there, start to see a reaction happening. And we can leave it in here for a little while if we wanted to, but really we've basically seen everything that we're going to need to see at this point. So I'm going to pull these out, and then it asks us to remove the battery cap to stop that reaction completely. I actually wanted to show you these 2 electrodes after the reaction. It asks me to wipe them off in the process of cleaning them up. But I did leave them in there long enough that you can see that this one attached to the black wire, the one that wasn't bubbling, is actually growing some stuff on it. It's this reddish stuff here. And after you write your equation and focus first on what type of reaction this has to be, if we're starting with that copper chloride stuff, after you figure out what type of reaction this is and figure out your products, you'll actually be able to identify what is this weird red stuff that you formed on this electrode. So let me go ahead, actually put a tissue here so you can see as I wipe it off, it comes off really easily. Now my electrode isn't red anymore. So that's that reaction. All right, so in reaction 4, tells us to obtain and observe a piece of magnesium. And this is actually the same magnesium ribbon we used before. It's just a little bit of a bigger piece here for you to observe, or maybe it'd be easier if I left them on the dish. So what it tells us to do next is light the Bunsen burner by turning on the gas and lighting it. It can barely be seen, but still kind of visible. That's not the reaction we're observing, though. We're going to hold this magnesium with the tongs in the Bunsen burner just to get this reaction going, and then we can pull it out, and this reaction is going to keep going until it uses up all of that magnesium. And I'll go ahead and turn off the Bunsen burner. You can write your observation, what happened during that reaction, and then this is what's left over afterwards. And what's more, I just barely touch it, and it falls, and the whole thing is kind of messy, but there it is. So our products, they are definitely very crumbly. Yeah, that's a better focus. That's a nice high contrast. You can see a little itty bit of unburned magnesium where I was holding it in the tongs itself. So that's our reaction 4. All right, here at reaction number 5, we are going to first observe our ethyl alcohol in this container before we do anything with it. And I'm going to put 1 or 2 dropperfuls on the table in whatever design we'd like. I'm going to kind of try and make a heart. And then, you know, light the heart on fire. Still going, little bitty baby flame there. And I think that went out finally. So we do have some stuff left behind on the table. I'm just messing with it with this tweezer so you can see it is the actual stuff that's left behind. And once again, that's something that was formed in this reaction. And I think if you write this equation out and predict those products, you should be able to figure out what that liquidy stuff that was left behind on the table is. Because just in case you were wondering, it's not alcohol. It's not lighting on fire. In fact, that's interesting. Even this fire on its own on the table kind of leaves these little moisture patches. Interesting. Well, make your observations rather. You've probably already observed it. Write the equation and balance it. Let me know if you need help with any of these, but you should be able to at least do observations for each of them without much help. And then we'll just have to worry about writing and balancing the equations. And part of that is figuring out their type. So, best of luck to you.